Okay, now we go on with the next example. So what if we have a look at your notes here. So let us try. So we have tried the first one, so I'll show you for the okay. So we see there's called repeated factors over here. So let us do this B. I'll show you B. Okay, so example B. Okay, so B is Laplace inverse 4 over s minus 1 s plus 1 square. So as you can see, we have repeated factors over here in the denominator. so we don't have, again, we don't have functions like this in the table, so we need to modify the fraction into partial fraction. Okay, so now we have a over s minus 1, and then plus b over s plus 1 power 1, and then have another terms for s plus 1 square. Okay, so we need to find a, b, c to be substituted later. So a, b, c again, similarly for a, for example a, linear factors, so we are interested only to find a, b, c, so we have just look at the numerator of the expression. So okay, so now s minus 1, so cover s minus 1 multiplied by s plus 1 square. Okay, so b multiplied by, we have already s plus 1 over here, so we cover one of the s plus 1, left with s minus 1, s plus 1, and then for this c multiplied by cover s plus 1, cover s plus 1 square, so left with s minus 1, so like that. So now, so we have several ways to do it. We can use elimination as well for this, and then so now we have three constants a, b, and c. Okay, so we have a, b, and c. So that means if we want to find one of them, we need to eliminate two constants. So if we want to find a, so we need to eliminate b and c. Okay, so let us see. Okay, so let's try. If we want to find a, okay, a, that means we need to substitute, we need to eliminate b and c at the same time. So b and c, the expression involving b and c, have common factors s minus 1, s minus 1 over here. So we can substitute s equals to 1, so that means we can eliminate both b and c when s equals to 1. Okay, so when s equals to 1, so we eliminate b, c, so from here we can get a. So s is 1, so we have 2 of 2, so 4a. So b and c eliminated already. Okay, so got a straight away. It's a very fast way using elimination method. Okay, so to find b, okay, now similarly for b, so we have common factors for s plus 1 at b and then at a, so we can eliminate, we can find c by eliminate a and b by substituting the s with -1. So s equals to -1, we eliminate a, c, so we can get b from here. So 4 equals to s equals to -1, so 0 here, so 0 here, so multiply b, b eliminated, a, b can be eliminated, and a also eliminated. So we have s -1, so -2c, so c equals to -2. Okay, so the remaining constant is so we have a and c, so we have to find b. So in order to get b, we cannot eliminate a and c because there are no common factors a and c, so we need to find other ways to get b. One of the ways is by substitute the values of s, with any numbers. So with any numbers, because we have already found a, c, the only constant available here is b. So when we substitute s, a and c, so we can find b. So any values can be substituted over here. So we have, so what do we, the values, we just find the smallest values, the easiest value of s to be substituted into this expression. Okay, so we have already used a equals s is 1, s is -1, so why not we use s to 0 to be substituted into this together with values of a and c to find b. Okay, so 4 equals to, so we got a equals to 1, so we substitute a equals to 1, s to 0. Okay, so 1 for this expression. So b is to be found, so s equals to 0, so we have -1 multiplied by b, negative b, so this one is 0, so we have negative b here, and then s is 0, so negative c, so c is -2, so -1 multiplied by -2, we have 2 plus 2, so we get b. So b equals to 1. Okay, so now that we have a, we have c, and we have b, and then just substitute into the question. So now our fraction here is now this with a, b, c to be substituted. Okay, a equals to 1 over s minus 1. Okay, and b equals to 1 over s plus 1, and c equals to negative 2. So now that we have functions are ready to be inversed Laplace, because we have these functions in the table. So now for the first function, a is 1, so EAT a is 1. So minus a is negative 1 over here, so negative t, so 2, this is shifting. So if you do you can remember this is what in terms of t of n, right? So we need to identify the n is to 1, so 2, but this is first shifting property. This is not straightforward. We need to use first shifting property because we have shifting at s by negative 1 over here. Can you see? So we use this table, Laplace inverse of f s minus a. So we have e negative t EAT ft. Right, this one, sorry, this formula, if you see in the table, first shifting property. So now a, this is shifting, a is negative 1, so a negative 1, negative t. So ft, we need to inverse fs, inverse Laplace fs to get ft. So we need to Laplace inverse fs. This is fs minus a. Okay, this is fs minus a is negative 1, so plus 1. Fs plus 1 is here, so fs, this one is fs, so fs is 2. All the s plus 1 will be substituted by s here. See, this one becomes s plus 1. This one is fs plus 1, so we want fs, so all the s plus 1 will be substituted by s. So et, now it comes like this. So n equals to 1, so 1 factorial, so we take out 2, so 1 factorial is 1, so t to the power of 1, so 2t. Okay, this is the answer for B, kind of repeated factors just now. Okay.